All right, so sorry about the interruption, guys. So this is like part 2, or exactly how we make the fibrin clot. So what you need to do or know, again, prothrombin goes to thrombin. The thrombin again has many things that it's going to do, but for right now we're only going to talk about how thrombin takes fibrinogen to the fibrin monomers. Okay, so those are monomers, and I'll explain that in a minute. So your fibrin monomers spontaneously, all these monomer little pieces are going to make a fibrin polymer. So you're going to get bunches of these polymers. Now, in order to stabilize this fibrin polymer, I need my factor 13A. Remember, thrombin again is going to help 13 go to 13A. 13A is going to get my stabilized factor. Now, all right, once we have the stabilized factor, remember I said the minute that we make these fibrin, we're incorporating it so that it will dissolve. Okay, so the fibrin, the stabilized fibrin, is going to get a slow degradation, and then it's going to go to your fibrin degradation products. Now, the fibrin degradation products, you're going to have little pieces and big pieces. Little, or how do I put that in your, I do have little. So I have little pieces and I have big pieces. Now, the reason you have to know what these are is because in the laboratory, can you see that? Did I put little and big? Yeah, okay. So in the laboratory, we have different kits to pick this up, and it just depends. Is my kit going to pick up X and Y factors, or is my kit going to pick up D and E? And again, what they are is the degradation product of your fibrin. All right. Now, during a DIC and all those other things, my fibrin degradation product in that particular case is going to be pathologic. So, again, we can pick this up in DICs, etc. And so it also represents fibrinolysis. So your fibrin degradation products represents fibrinolysis. And we're going to get to fibrinolysis in another separate video. Alright, so I've got slow degradation of this polymer. So what you need to realize is what's being incorporated in here is going to be plasmin. So what happens is this plasminogen is absorbed in this clot. The plasminogen is going to go to plasmin. I'll be over here. Plasminogen is going to go to plasmin. Now, this plasmin has two actions. The plasmin is going to go back to help the degradation within the clot, and some of the plasmin is going to escape the clot. And when it escapes the clot, it's going to go back to destroy factor 1. What's factor 1? Right? Where's factor 1? It's going to go back and destroy factor 5 and factor 8. So, when the plasmin escapes and goes back and destroys 1, 5, and 8, it stops the coagulation process. So, just for an example, here's the 5. If I can't go to prothrombin to thrombin, if I can't go to 2, then it's going to stop. Factor 1. If I can't get from fibrinogen to fibrin, it's going to stop. So you can see, as it's slowly degrading, it's going to also tell the body to stop making clots. Okay, well, where in the world does the plasminogen come from? The plasminogen can come from, or be activated and come from intrinsic pathways, extrinsic secretions that we have, and exogenous forms. I'm going to get to exogenous in a minute. So your intrinsic activators of your plasminogen are going to be your high molecular weight kininogen, calcrinin, your 12A, and your 11A. So where was 12 and 11A? In the intrinsic pathway. So it's going to help activate your plasminogen so that by the time the 12 goes all the way down to the 10, goes all the way down to prothrombin, goes all the way down to fibrin, it has stimulated plasminogen so it can be incorporated. Okay, secretions, also like tears, saliva, semen, breast milk, and urokinase. Okay, now the exogenous forms, that's what we call the clot busters. So if someone is coming into the hospital emergency room and they're having a stroke, we want to give them a quote-unquote clot buster, which is an exogenous form of an activator that's going to get plasminogen to plasmin to dissolve clots. Okay, so again, one of these exogenous again is urokinase, the same thing like a secretion. Streptokinase, which we manufacture it, but it comes from your strep, and tissue plasminogen activators. So those are your exogenous, and they can give it to a patient that's coming in with a stroke. All right. All right. So, well, if it's escaping here, how in the world is it going to be kept in check? Well, plasminogen is kept in check once it's escaped because it has antiplasmins. So antiplasmins, okay, so it escapes, but I have to have an antiplasmin. Antiplasmin. What are the antiplasmins? Alpha 2 antiplasmin and alpha 2 macroglobulin. All right, so the alpha 2 antiplasmin and your alpha 2 macroglobulin are going to act like your antiplasmins, which means they're going to go back and they're going to chomp up and destroy the plasmin that has escaped. All right, let me see. Okay, and remember, I don't know if you remember in serology, but you should have talked about alpha 2 macroglobulin and alpha 2 antiplasmin as acute phase reactants. Remember, acute phase reactants, we check to see if we've got inflammation and all that stuff going on. Wow, so what did you think about that? So this is actually how we make the clot. So remember, all of these coagulation factors are occurring and getting the platelets to stick together. And how they're getting it to stick together is by they're making these fibrin clots or fibrin strands in between the platelets. All right, so we have to do, remember the goal was to get to fibrin. So fibrin, once we get to fibrin, we're going to make it stable with factor 13A. Once it's stable, it incorporates inside of it your plasminogen. Your plasmin, did you notice I almost tripped over myself? The plasminogen is incorporated into here. It's a slow degradation product. All right. Your plasminogen gets into plasmin and it's being activated. Plasminogen is being activated by intrinsic factors, extrinsic factors, exogenous factors, and secretions. And again, as a self-check, the plasmin is going to escape and it's going to stop the actual coagulation factors with your 5 and your 8 and your factor 1. And in order for that to stop, my body's going to say, okay, that's enough plasmin out there. It's going to have alpha 2 antiplasmin and alpha 2 macroglobulin. Whoa, that is pretty amazing. Now, I'm going to explain now. Remember I said, so as it's degrading, it's going to degrade down to fibrin degradation products. And we have little pieces and big pieces. And so what I'm going to do right now is kind of explain that. So in the laboratory, the testing that we're going to check for fibrinolysis and for DIC are your fibrin degradation products, or they also call them D-dimers. Okay, so we're going to have our fibrinogen. Your fibrinogen is made out of different pieces. Okay? So when we look at fibrinogen, I have an E and I have a D. And then I have smaller little pieces. We have A's and B's and A's and B's. Okay. So your fibrinogen is made out of pieces. And when plasmin takes these pieces apart, that's where we get degradation products. Now, see these D's? In the laboratory, I can check for D-dimers. D-dimers. So D-dimers is a test that we're doing in the laboratory to check to see if I have a DIC, and what is called a D-dimer test. The D-dimer test is checking for the pieces of D of fibrin. Okay, so that's your fibrinogen. Fibrinogen is then going to go down to, remember I said we had fibrin monomers. Fibrin monomer. So what the fibrin monomer means is that this is broken down into the little pieces. So now I have D's and E's. Okay, so now I have my D's and E's. Well, how does it get there? Okay, it gets there by thrombin. Well, how did I get to thrombin? Prothrombin had to go to thrombin, and thrombin's going to make that. Now, remember I said that spontaneously I'm going to get fibrin polymers. Fibrin polymers. So what happens is spontaneously I'm getting all of these products that are going to be lining up with them. So remember that D has to go EDD, EDD. So then I can have an D, E, D, D. So then all of these EDDs line up to each other and make a polymer. And you need to remember that this is going to happen spontaneously. It's kind of like if you had a bunch of magnets together. Remember, they kind of attract to each other. So these little monomers are going to be attracted to each other, and they're going to get stuck together. You know, the E's have to get with the D's. The D has to get with the E, so it makes these cross fibers. So then we get that. Now, what's going to happen now? Remember 13. 13 has to stabilize it. So then we're going to have a 13, 10, 11, 12, 13A is going to stabilize it. And then I get a stabilized fibrin polymer. So that is so cool. That's the way we make our fibrin product. That's how we do that. And that is like really so cool. It's just totally amazing. Let me see here if I've missed anything. Naturally occurring. Let's see. So again, you've got all my notes. Plasmin. Oh, I erased it. Liver. Okay. All right. I think I've done all that. The next video is going to be, or maybe I can try to do this. Yeah, let me see. Let's just see if I have enough time. Your fibrinolysis. Okay, so I already said that. Plasmin, antitrypsin, I've already said all that. Fibrin degradation products, I've covered that. And, alright, so, okay, so it looks like all that's happening. So, again, what's going to take this apart in fibrinolysis? Your plasminogen, and your plasminogen goes to plasmin. Plasmin breaks up these bonds. Once the bonds are broken up, I'm going to pick up D-dimers, etc. And depending on your kit, I can get the big products or I can get the little products. And that's the way we do it. So that was so cool. Let me know if you've got any questions. And thanks. Bye now. Sorry for the interruption. Okay, bye now.